Hi guys, Dr. Diaz here again. Now we move into chapter 10, Conic sections, and the first formula we're going to discuss, the first equation is going to be the distance formula, which is similar to an equation that you've seen before, the Pythagorean theorem. Okay, so let's go here, read this one. It says the distance d between 2 points, or between the points, well, 1 and 2, or say x1, y1, and x2 and y2, is given by this equation. How do we calculate this? Well, let's give an example. Suppose we have 2 points, say -2 and -3, and the other point is, let's say, 3 and 4. We're going to calculate the distance between those 2 points. If we go here to our Cartesian coordinates, when x is -2, y is -3, the point is somewhere here. The other one is when x is 3 and y is 4, is somewhere here. So basically we're calculating the distance of this line. Let me see if I can draw this line nicely. Okay guys, I had traced that point. It took me a while to do it, but there it is. And well, we know this point. This is when x is 3 and y is 4, and this one is when x is -2 and y is -3. And if you remember, if you do this something like this, and now you see how ugly it is, and this thing going down all the way down there, we have what, more or less a rectangle triangle. And if you remember, this will be the hypotenuse, and the hypotenuse square is going to be the sum of the side square, which is actually the Pythagorean theorem. Sorry about that. Hello? Okay, sorry about that. Change a little bit this equation and fix a little bit that triangle. So now what we're going to do is calculate this distance, the distance between these points, -2 and -3, all the way up to this point, 3 and 4. And by that we were using the distance formula. The first thing we should do is we should label each of these elements. Like we call this one x1, and this one y1, and this one is called x2, and this one y2. Then we go here for the distance between these 2 points. It's going to be the square root of x2, 3, minus x1, -2 square, plus y2, 4, minus y1, which is -3. Oh, look at that. Square. So this end up being what? The square root of what? 3 minus -2 is going to be 3 plus 2 square, plus 4 minus -3 is going to be 4 plus 3 square, which is going to be what? Square root of 5 square plus 7 square. It's going to be the square root of 25 plus 49. And this is going to be the square root of 74. Right? Yeah, that's it. So the distance between this point and this point is going to be 74 units. We know what it is. But suppose that we were measuring this in centimeters, so then in this case it's going to be the square root of 74. Actually, it's not 74, it's the square root of 74. Sorry about that. Square root of 74, which is around, let's say it's 8 point something, but 8.6. So we put here 8.6. Yeah, and let's say the thing was measured in centimeters, but then we put the unit centimeter. Okay, good. Okay, guys, you can see the examples in the review about the distance formula. Now let's go move to the next Conic section, in this case the circle. The circle. And the circle is defined as what? Well, here it is the set of all points in a plane that are equidistant from a fixed point called the center. The fixed distance from the circle's center to any point is called the radius, which actually means if we have something like this. Now if you look here, this circle, look at this circle. Any line from the center to the edge of this thing, it measures the same, and it's going to be, as you can see here in this circle, any distance from the origin to the edge is the same, and that is called the radius. Now, this equation here, well, first talking about this equation, let's talk about the equation of a circle centered at the origin. That would be something like this: x squared, it will be x squared plus y squared is equal to r squared, with the center, the center is at the origin. Like if I give you an example, this one, x squared plus y squared equal to 4. Well, the center for this circle is 0 and 0, the origin, and the radius is going to be the square root of 4, which is 2. What it means is from the center, you're going to move 2 units to the right, here, 2 units up, here, 2 units to the left, here, and 2 units down, here, and the circle, if you put numbers, points like that, more or less, here's a circle. You see? Yeah, there is more or less a circle. Yeah, well, it's not bad for doing it using this crazy stuff. Here's a circle. This is a circle centered at the origin. Yeah, please draw circles, not potatoes. And the potato is not a circle, looks like more like an asteroid kind of thing. Alright, so now in a second we're going to study circles that have different center, not center of the origin, but center what they call H and K. And here is what I was talking about, is the standard form of equation of a circle, which the center now is HK and the radius still R. Right? If you look at the PowerPoint, they have some examples about these type of problems, and let's see one of them. But before we see that, then, well, let's try here an example. This will be an example of that circle: x minus 3 squared plus y plus 2 squared is equal to, let's say, 9. Well, the center, the easiest part is to find the radius. The radius is going to be what? Square root of 9, which is 3. But the center here is, when it's minus 3, it's going to be then positive 3, and when it's positive 2, then it's going to be negative 2. So if we're going to draw this circle in the Cartesian coordinate, let me erase this in a second, then what we have is we go to the center. The center is, when x is 3, y is negative 2. So the center of the circle is here, right? And then we use the same approach we use it. Well, radius is 3, so we're going 3 units to the right. So, oops, okay, of the chart. 3 units up, so 1, 2, 3 here. 3 units to the left, 1, 2, 3 here. And 3 units out, 1, 2, 3 here. So here's our circle. Goes something like this. There is our circle. Well, this second part doesn't look decent, but there is. This is our circle. Center at 3 and negative 2, and radius 3. Cool, isn't it? Yeah. We discussed then later the general form of the equation of a circle, because this one we just study here or analyze here is the standard form of the equation of a circle. For the general form of the equation of a circle, we will have another video because these are a little bit slightly complicated, but we're going to do it in a second. Okay guys, take care and see you in a second.